Yeah, good amount. Awesome. Anybody use it for anything other than data analytics? Okay. Hopefully we'll cover something interesting today then. So big question comes up, is automation worth it? A lot of times it's really easy to get into a problem, say, I want to fix that. I want to make it that problem never happen again. But we run into a cost benefit analysis of, did I spend more time than it's ever going to impact me to fix that and automate that? And I'm a fan of XKCD comics, so these are good examples that illustrate sort of that issue of when is automation not worth it? And I like to think everything in that green area, you need a different solution. Spending time trying to automate something probably isn't worth it unless it's going to take you a couple minutes. So when we talk about automation, we can think of it as not only fully automating something, but also documenting. And so really the use case I'm going to demo today is using Jupyter Notebooks as a functional construct to improve your documentation and improve your accessibility to individuals in operational teams or security operations teams to use that information. So we'll step through a few pieces. It'll be quick because we've got a limited amount of time, but definitely really enjoyed talking about this stuff, really enjoy sharing what we're using for this stuff. So if you have questions, happy to spend time afterwards. So what is Jupyter? If you're not familiar with it, it's three major components. You have a notebook, which is a file format. Under the covers, it's just a JSON document. So ultimately code cells, markdown cells combined into a single document. Code cells can be executed live. Markdown cells are just text content. An interactive protocol. So 0MQ generally is how the notebook interfaces with the actual execution environment. So the backend kernel, and that's the third component is your kernel. And that's actually running an instance, a process instance of a different runtime library. There are many. We'll show an example using PowerShell today. So a little bit less familiar, but Python also is super popular. And then there's even if you're like super into object oriented and you're doing something like OCaml or F#, there's even support for pretty abstract languages. So plenty of options, plenty of possibilities, makes it very accessible. The other aspect is to author. So everything up to this is usage and then authoring. Within Visual Studio Code, the simplest way to author is using a Polyglot Notebooks extension or using a different notebook extension. Polyglot will help you with all the .NET Interactive functionality. If you use Anaconda, Python, or another Python distribution, those are also supported as well. So how can we get started? Like I mentioned, you need some editor that supports working with notebooks, IPYNB files. So Visual Studio Code, fantastic platform for that. You'll need, at least on the PowerShell side, the SDK, so the full .NET SDK to be able to install and use the kernels. And then you'll need the extension for polyglot extensions if you want to be able to interface with those kernels that are installed through the SDK. From a Python perspective, this is what it would look like. You can change your flavor of Python distribution. Like I mentioned, you could use Anaconda, Miniconda, Core Python, and then as long as you just have an editor extension within Visual Studio Code, you'll be able to interface pretty seamlessly. So how can you use this? Getting into a demo really fast. Wanted to put together a super simple example of how can you operationalize using a Jupyter Notebook. If you aren't familiar, this is a diagram built in Mermaid. Mermaid is a JavaScript framework that effectively lets you generate SVG files from plain text. And Mermaid happens to be a kernel that's supported by Jupyter. So in this use case, this example, we have a very, very simple website, arguably a poorly architected website, but it is hosted on a single EC2 instance. It is behind a load balancer, and we just have it front-ended by that by Route 53 for name services. So in the instance, we had an outage. I know I have definitely accidentally turned off the wrong instance at times. So sometimes accidents happen, sometimes things break, sometimes it's a little bit more elaborate than somebody making an accident. But let's just say our instance got shut down for whatever reason. Our website's offline. What's going to happen? In the background, what that just did is it triggered an Event Hub task policy. Event Hub in the background saw that that instance, that critical instance was shut down or stopping. It triggered an API call to start up a new Jupyter instance running on our Fargate cluster. And that Jupyter Notebook instance is pre-populated with a GitHub repo that has a troubleshooting notebook. So it also emailed our engineer, hey, here is your runtime environment where you can start to troubleshoot this issue. So engineer receives simple error message. You can replace this with PagerDuty. Maybe you're using a ITSM platform like ServiceNow, and it's going to handle your incidents. Super simple example, but wanted to show you what it looks like that you can have dynamic interfaces for engineers to be more enabled in their roles. So if we click this link, right now it's downloading that GitHub repo and it's starting up an instance and it's dropping me right into a notebook that says, hey, here's our website recovery procedure, get started. As I mentioned, Jupyter Notebooks are markdown cells and code cells. This is an example of a markdown cell, and then this is an example of a mermaid cell. So if I run the mermaid cell, you can see on demand, it generated that SVG, gives you an idea of the overview of what this document's going to cover, what steps you're going to walk through. Oh, and just super quick, both the JupyterHub instance and the Jupyter Notebook instance that got spun up ephemerally are both just in a Fargate cluster. So with all good documentation, having some context of prerequisites is always helpful. We don't want to assume anyone's environment's always operationally perfect. We're also at the luxury in this instance that since we're running our task in a Fargate task, we now have an operating environment that's in a secure environment. So we authenticate into this instance, and now that instance is already on our secure operating area. We've associated an IAM role to that task, and that task is able to effectively work without us needing to further authenticate or do secondary authentications. Lots to consider in that. So make sure that you aren't over permissive, providing excessive permissions automatically, but definitely can streamline operations. So just quick test, we see, hey, the website's responding with 503, to be expected. We know it's down. So maybe we're an engineer who wasn't the engineer who shut down that instance. Hopefully if we were, we would just know to turn the instance back on. Maybe we are a NOC team responding to an incident on third shift and somebody in the EUs who actually ended up shutting down that instance. So we have no context that someone just shut down an instance. Maybe our logging isn't clear enough. Maybe it's a more complex issue than that. And so we want to get context over what the service is, how it's structured. All we know is that this website URL is where we can't get to. So we'll work from the inside or outside in. We'll figure out, hey, where does that domain reside in our accounts? That hosted zone, can we get the record sets? Once we've got the record sets, can we identify the target of the record that we actually care about? We see that that is actually an elastic load balancer. So if we look at that ELB, We try hitting the ELB directly and we just skip the certificate check because we know it won't match, at least in this case. It's still also responding that it's failed. So now we know that, hey, DNS is resolving. We know that the DNS record's pointing at an ELB. We know the ELB is not responding. So we get that ELB and we try to identify what is behind the load balancer. Get the target group and the configuration of where it's routing that traffic. And we can see that, hey, the health over our target is unused. Great. Let's get more information on that instance. Let's see why it's failing its health check. And then if we try that instance directly, so we build out a URL request using the information from all of our internal information. So the internal IP address, the health check protocol, the port, and the endpoint that the health check is looking at, we can see that even that fails. So we know that something's wrong probably with that instance, which is our only target in that target group. So if we get information about that instance, we see, oh, the instance is stopped. Let's make sure, double check that it's the instance that's stopped, that's the issue, and then we can begin remediate. So we start that instance. Once that instance is started, then we'll run through our procedure again and make sure that everything checks out for the entire life cycle that we've seen. State is still pending. And now we're getting a 200. So we know that the website's back up, at least from an internal perspective. We just tested with the ELB endpoint. We can see that the ELB is responding with the 200. And if we go all the way back to our true internet-facing endpoint, we can see that we're still getting a 200. And if we go to our website, refresh, it is truly presenting a 200. And so this is a very simple example. This is a very simple architecture, but it illustrates something that we've started to use with our engineering teams. There's a lot of concepts that can be unfamiliar. AWS environments especially can be very dynamic, and you may not have the context of someone who built that service. So can you provide context, at least at a high level, of things that you could start looking at for a junior engineer or even a mid-level engineer, and they at least have a baseline of, hey, here's where I got stuck. I'm escalating you to you because I got this far in our procedure and I failed here. We can also pivot that and start to say, well, documentation is really challenging. So can we do something with our knowledge base articles we already have and start to build out functions or scripts that wrap around our existing knowledge base articles? Or vice versa, if we have existing remediation scripts, can we flip those and write documentation around those existing scripts? So summarizing a little bit about what that experience looks like from an employee, we're building confidence, we're getting baselines of skills. We can have a lot of engineers come and go. I work in an MSP scenario, so definitely having some turnover is painful, and a definite onboarding experience and making sure that somebody becomes integrated into our environments and our ways of functioning very rapidly is valuable. And so if you have large teams, any level of documentation starts to enable those team members faster. We touched on JupyterHub as well in that demo. So Jupyter Notebooks is the engine that you saw me running through the steps in. And then JupyterHub is the interface where we sign in, we actually interface with the notebooks from. And so that's actually, you can see that here. So we can add name servers, we can add tokens if we want to work in a server from VS Code or remote environment, or even do API calls. And then as an example, the Jupyter Notebook server is this view that you saw. And so from a cost perspective, those Jupyter Notebooks are spun up dynamically. All that you're running is a single service in a Fargate container for a JupyterHub web server, and it's very minimal. So your ELB costs on front-ending that service in Fargate are actually more expensive than the compute costs. And it gets you a centralized management plane. It does enable SSO. I didn't show that because it was already logged in. But as an example, this actually is front-ended with Azure AD for our enterprise authentication. So if I am Alan and I'm already SSO'd into our identity provider, wherever that is, you can be SSO'd into JupyterHub as well. Other use cases, so privileged and remote access. Like I mentioned, that task got spun up in the AWS account where the incident occurred. So by redirecting an engineer directly into the environment where they need to begin troubleshooting, we don't have to worry about VPNs. We don't have to worry about, did you log into the right console? We don't have to worry about, hey, is your AWS SSO key timed out? You are in the environment. So if you can log in through your SSO, your primary IDP credentials, you're in that environment, ready to begin troubleshooting. You get multi-language support. So examples of that being, we have, I showed some PowerShell examples. PowerShell is just my preferred language. Python fully supported. We have also use cases where maybe it's netconf or restconf. So being able to interface with hardware equipment. So if maybe you have your direct connect circuit paired on-prem with your own equipment and you see ports flapping on your on-prem equipment. So you can enable hybrid scenarios with this as well. And then, as I mentioned, documentation is time consuming. Whether you have the documentation or you have the code, you can potentially use tools like we saw earlier in the keynotes around large language models to be able to start growing that documentation and adding more context to that documentation. Asking for code samples from prompts can be a little bit iffy, but the opposite is pretty successful. So giving it existing scripts and saying, hey, can you provide me a summary of what this line is doing? That's something that I've seen work very recurringly very well and very consistently. And we go back to the XKCD comic. We can't automate everything. We have to choose our battles, and we have to try and scale our team members and empower our team members as much as we empower the organization. And so if every second counts, then make sure that you're investing those seconds in automating the right things and getting good documentation or enough documentation and being efficient in your documentation in other areas. And as Werner would say, everything breaks all the time. So make sure that you have a plan. So who am I? National Director. As I mentioned, MSP, MSSP. My focus areas, migration, identity security, hybrid use cases. So traditional data center is where I came from, enterprise networking. But love talking about AWS, work in AWS pretty regularly. It's part of my day-to-day job. So, but multi-cloud and such as well. But AWS is definitely my preference to build on, just because it's the platform that gives me the most control and the best outcomes. A bunch of references. So if you've got more curiosity around the different topics we touched on, there's a lot we touched on very rapidly. So definitely this is a starting point. There's even more you can do with a lot of this, but huge communities out there that are integrating this. As an example, Doug Fink has a PowerShell AI module that integrates with the notebooks. So you can actually do a prompt in one code cell and it'll return the next code cell with the content that the prompt generated. So if you, I did an example or a demo of this in April where I asked it to program in PowerShell FizzBuzz in as few characters as possible. And it came back with an example of FizzBuzz that was like 40 characters and it was functional. So prompt, next cell, ran it, worked. So that's it. have a few minutes for questions. Anybody want to get into it? Yeah. Yeah, and so the question being secrets management, and are there strategies for sort of unique secret use cases? Yeah, so in this demo, Azure AD application API keys for the OAuth authentication for the SSO is in Secrets Manager. The API secret that EventBridge used to call the JupyterHub instance is in Secrets Manager. And then we used IAM roles at the task level. Scaling that into an individual has been challenging. So generally, what we try to do is scope that role assigned to the task based on an environment. So if we have engineers we know are supporting a specific environment, we're going to assume that that engineer, if they can access the instance that we spin up, has that role trust. So there's an implied trust there for sure, but that's generally how we handle it, is based on the user identity who's accessing the environment. Other questions? Yeah.
We thought about integrating, so I found that so in your example, an EventBridge event goes off, right?
Mm-hmm.
And then that triggers the spinning up of that Jupyter notebook in your own Fargate cluster.
Mm-hmm.
We thought about integrating that into like SageMaker or SageMaker notebook instance or anything like that, just to pull together a more cohesive managed service offering rather than custom stuff.
Yeah, good question. So to summarize, integrating with SageMaker or other native services to sort of simplify and replace that unique task instance. Is that fair?
Yeah.
Okay. So yes, definitely a couple examples of that would be SageMaker itself, but also Systems Manager has some playbook functionality built into it as well. What I'd say is one of the benefits of doing your own Jupyter Notebook instance is you can load any kernel you want. So you get a full Docker instance. In this instance, we used NB-Git puller, which using query parameters in the URL accessing that Jupyter Notebook instance pulls down a Git library, but you may have 200 repos and you want to preload all of them onto your notebook server or centrally locate them and mount them dynamically or something to that effect. Yep. And so there's definitely availability or possibilities. This just allowed for the most customizability. Yeah. Awesome. Yeah. Yeah, so good question. So can you have different Fargate tasks for different incidents? So yes, 100%. So within JupyterHub, you can utilize name servers. And so you have either individual servers or name servers. And a name server, we actually used an individual server in the demo just because it's a little cleaner. But with a name server, when you call the API, you can just specify a name for a server. It'll spin up a task for that specific service or server. And you could even name that individual notebook as an incident number or a case ID. And at that point, you'd have shared tasks dedicated to an incident. Yeah. Awesome. Thanks, y'all.
I hope you're having fun at the